In this video we have to calculate our K, which is the constant. It's a half-life problem, so we're going to be given a substance, 4 grams of it, and then we want to figure out the rate at which it decays, which is represented by that K. Now I'm going to use this formula right here. The A represents our final amount, P is the amount that we start off with, like I said that was 4, and then K is our constant. T will represent the time that it takes for our substance to go from 4 grams to 2 grams, which is of course half of it. So with that said, half of our initial starting point would be 2. Alright, so I'm going to plug in 2 for A, and then the initial amount that we're starting with is 4, so that goes in place of the P. E is the standard right here, and then our K, we don't know that, and then our T is 32, and that's going to be in years. Now we want to isolate this part right here, the E. So to do that we want to divide out this 4. So we divide everything over here by 4, which means we have to divide that side by 4, and then when we simplify we have 1/2 equals E to the negative K times 32 power. Now for half-life problems you could actually use this as a starting point, because we know whatever value that we start off with right here, we know that this value is going to be half of it, and then to solve for either K or T we always have to divide out our initial value first, so we're always going to end up with 1/2 here. Now the next part would be to take the natural log of both sides. So if I have 1/2 on the left side, I want to take the natural log of that, and then that will equal, we need to take the natural log of this right side, okay. Now the natural log of 1/2 is going to be about negative 0.6931. That will be an approximation, and then when we take the natural log of base E to the negative K 32nd power, that's going to be just a negative 32K, because we use this formula, natural log base E of X, that actually equals just X, whatever be the exponent of the E. Now we continue to solve this, so we have to divide both sides by a negative 32. So that cancels, I'm left with K on this side, and that will be about 0.0217, and that will represent my K, which is the rate at which our radioactive substance will decay from 4 grams, and then it'll take 32 years to get to 2 grams, half its original amount. So that's about it.